What if an AI could actually teach itself to get better? And I don't mean the slow, tedious training that we do. I mean a system that just improves all on its own. It's honestly one of the most powerful ideas in AI right now, and we're going to break it all down.
Seriously, just stop and think about that for a second. Imagine you give an AI a task. You go to bed, and when you wake up, it's run hundreds, maybe thousands of tests on itself, and it's now way, way better than when you left it. Well, that's not science fiction anymore. It's the core idea behind a project called AutoResearch. So what is this thing really? Well, you can think of AutoResearch as a framework that lets an AI become its own personal scientist. It comes up with a theory, it runs an experiment, it checks the results, and then it makes a decision. Keep the change or scrap it and try something totally new. It's this relentless, automated loop of self-improvement. Now, the minds behind this is a true heavyweight in the AI world, Andrej Karpathy. You might not know the name, but trust me, you know his work. He's a co-founder of OpenAI, and he was the guy leading Tesla's autopilot team. So yeah, when he puts an idea out there, people really pay attention. And this one could be a massive game changer. The whole idea really started when Karpathy was spending months just manually tweaking a model. And he asked himself a really simple question. Why am I the one doing this? His answer was AutoResearch. He boiled the entire complex process down to 3 incredibly simple things. Give the AI one file it's allowed to change, give it one number to measure success, and then just let it go, constantly trying to make that one single number better. Okay, so how does this loop actually work? I mean, how does an AI run its own experiments without a human looking over its shoulder? Let's get into the mechanics of it. All right, here's the cycle. First, the AI comes up with a hypothesis, a guess about how to make things better. Like, hey, what if I change this line of code? Second, it goes ahead and actually modifies the code. Third, it evaluates the result against that fixed metric we talked about. And finally, and this is the most important part, if the score got better, it saves the change. But if it didn't, or if it got worse, it just throws that change away completely and starts all over with a new idea. It's just simple, relentless trial and error, but at machine speed. And the system Karpathy built for this is just beautifully simple. It's all based on 3 files. First, you've got program.md. That's where you, the human, write down the goal. Then there's train.py. Think of this as the AI's sandbox. It's the one and only file the AI is allowed to mess with. But here's the genius part. The third file, prepare.py. This is the scoreboard, the metric. And the AI can never ever touch this file. Why? It's to prevent cheating. Because if it could, the AI would just change the definition of winning to whatever I just did. This rule is what keeps the whole system honest. So we've got this super powerful automated loop. But here's the thing. If you're only thinking about this for training AI models, you are thinking way, way too small. This simple idea, one file to change and one metric to measure, you can apply this to almost anything you can think of. Let's take marketing. A good marketing team might run, 30 A/B tests in a whole year? Now imagine pointing AutoResearch at your website's headline. The file to change is just the text of that headline. The metric is the conversion rate. That AI could test thousands of different headlines overwrite and tell you which one is the absolute best. Or how about finance? The file to change could be the rules in a trading algorithm. The metric could be its risk-adjusted return. The agent could then run that strategy against decades of historical market data, tweaking it hundreds of times to find the version that's the most profitable and the most stable. And this one is fantastic for any developers out there. You could just point this agent at a piece of your code. The file is the code itself, and the metric is how fast it runs. Then you just tell it, make this faster. And the AI will just start refactoring, optimizing, and trying all sorts of crazy things to shave milliseconds off the execution time, all by itself. And this leads to a really profound shift in what we value. I mean, if the AI can do the work, the optimization, then the human's job completely changes. The execution of a task becomes cheap, almost free. So what becomes the truly valuable skill? It's defining success, knowing exactly what to measure, picking that perfect metric. That becomes the new frontier. That's the million-dollar skill. But okay, let's get real for a second. This isn't some magic wand you can wave at any problem. To use this effectively, you have to understand the rules of the game. You need to know when it's going to work brilliantly, and just as important, when it's going to completely fall flat. For this whole thing to work, there are basically 3 non-negotiable rules you have to follow. First, you need a crystal clear metric, one single number that screams, "This is better." Second, the whole evaluation has to be automated.
The moment a human has to step in and give something a score, the loop is broken. And third, the AI has to have that one clearly defined file to play in. No more, no less. So really, the key difference here is between objective and subjective tasks. AutoResearch is incredible for measurable things like code speed or website conversions, but it's useless for tasks where better is just a matter of opinion, like designing a logo or improving user experience. If success is a gut feeling, the AI has literally no idea what to aim for. So where is this all going? What's the end game? Well, Karpathy has a vision for this that is so much bigger than just your personal projects or my projects. He makes this amazing comparison to SETI at home. You know, that old project where people would let their home computers help search for alien signals in space? Now imagine that, but for AI research. A huge distributed network with millions of these little auto-research agents spread across thousands of computers, all running experiments, all sharing what they learn, and all working together to push the boundaries of AI forward. It's a pretty mind-blowing vision. And that brings it all right back to you. Now that you know the framework, one file to change, one metric to measure, the real question is, what are you going to apply it to? What part of your work, your hobbies, your world is just waiting for a relentless, tireless agent to optimize it, while you focus on the one thing the AI can't do, deciding what better really means in the first place? That's the thought I'll leave you with.